This will be part 4 of lesson 2.7. Last time we talked about the linear pair postulate. If you notice that you have a linear pair, you can say that those two angles are supplementary, or you can say that their measures add up to 180. Either is acceptable. We also looked at the vertical angle theorem. We know that vertical angles are congruent. We're going to prove this in this video. And we're going to prove it using the stuff that we just learned. This linear pair postulate, as well as your congruent supplements theorem. So as we're going over these theorems, you might be wondering, well, what in the world do we need these for? Well, this is the reason. They save us time when we prove other things. So vertical angle theorem says that vertical angles are congruent. We want to prove this so we can use this anytime we want to prove something else. So we're given that angle 5 and angle 7 are vertical angles. Clearly they're vertical in this diagram. Can you prove that angle 5 is congruent to angle 7? Okay, so our first step would just be to write down the given. Okay, so angle 5 and angle 7 are vertical angles. Now, step 2 doesn't really follow from this first step, which a lot of times, if they use a term, you would define that term. We're not really doing that in this case. Using the definition of vertical angles isn't going to help us here. We need to look at the diagram and notice something. You should notice something about angle 5 and angle 6. And you should notice something about angle 6 and angle 7. Hopefully, this makes sense if you've been watching the other videos. I'm going to say that angle 5 and angle 6 are supplementary angles. Don't they make a linear pair? Also, angle 6 and angle 7 are supplementary as well. I'm just noticing this from the diagram. If I notice that I have a linear pair, I can say that the angles are supplementary. That's what we talked about in the last video with the linear pair postulate. So, me using this linear pair postulate saves me a lot of work in this proof, because I don't need to state all of this stuff as 3 different steps. I can just state it as one. So now we have 2 angles, notice, that are supplements of the same angle. Does that sound familiar? Two angles that are supplements of the same angle. When you have that, what do you know about those 2 angles? They're congruent. So you have all this information that you need to use. If you really don't understand the theorem or the postulates, you're not going to know where to apply them. And sometimes that takes time to develop. But that's what we're looking for here. If you can't do it on your own right now, hopefully you can at least follow it as I'm doing it. So 2 angles are supplements of the same angle. So what does that mean about those 2 angles? They need to be congruent. By the congruent supplements theorem. I just proved that angle 5 and angle 7 are congruent, and they're vertical angles. I proved that the vertical angle theorem works. And I used the linear pair postulate and the congruent supplements theorem that we learned in those other videos. If you didn't have these 2 tools or these 2 shortcuts, you would be writing maybe like an 8 or 9 step proof, and you don't want that. So take advantage of learning your theorems and your postulates. It saves you time. Okay, so we just proved the vertical angle theorem. That means you may use it in another proof. Okay, so try this one. This is a 4-step proof. Here's a diagram. They're telling you that angle 5 is congruent to angle 6. So I can put matching arcs there. There's one arc on each angle. They're congruent. Just knowing that, and obviously anything else that we've already went over, do you think you could prove that angle 7 is congruent to angle 8? I think you can do it. But do you think you can do it in the most efficient way? If you use all the things we learned in this section, you can do this proof pretty easily. Otherwise, if you don't, you're going to be taking the long route, and you're going to be doing an 8 to 10 step proof potentially. Okay, so angle 5 is congruent to angle 6. Terrific. What else do we notice about the diagram, about these pairs of angles? Some of you might say there's linear pairs, and that's really good. You could go that route, but that's the longer route. Think about what we just proved. Didn't we prove that vertical angles are congruent? Use that. Do you see vertical angles? Angle 5 and angle 7 are definitely vertical. That means that angle 5 is congruent to angle 7 by the vertical angle theorem. If you want to go to another step, you can. But also notice that angle 6 and angle 8 are vertical angles. So I can put that angle 6 is congruent to angle 8 right there. It's the same reason. If you want to split them up, you can. So now we have pairs of congruent angles. I'm going to talk about it because I just did it. This is what a lot of students do. If you have congruent angles, it's really natural to say, well, that means their measures are equal. And that's good. You could do that. It's not wrong. But if you do that, you're just kind of putting in a lot of information that isn't wrong, but isn't getting you any closer to this. Okay? We know these two angles are congruent. We know these two angles are congruent, and these two angles are congruent. We can make a statement just looking at this and this. You see how these two angles are congruent to the same angle? What does that mean about angle 6 and angle 7 then? It means they're congruent to each other. That's your transitive property of congruence. Now look at just this statement and this statement. See how you have two angles, angle 7 and 8, that are both congruent to angle 6? And that means angle 7 is congruent to angle 8 by the same transitive property of congruence. If you wanted to push these both into one step, you could. I think it's easier to read and follow if you separate them. Okay, so this is the most efficient way to do it. That's about a 4-step proof there. You could easily go down the wrong road and start putting in true statements that really aren't getting you here any quicker.